Well, hello and welcome back to my workbench. It is time once again to try to fix something, and we're going to be taking a look at another supposedly dead, completely dead PS5. And I do apologize now, my voice is not 100%. I have been a bit under the weather, getting better slowly, but it's still not quite where it should be. But let's see how dead this PS5 is, shall we? I've got it connected back there to AC power. Just need to turn this on. Let's see if that power supply kicks over. Yes, yes, I do believe that PS5 supply is starting. So we're going to have a mainboard problem then. No, nothing on eject. No beep whatsoever. Okay. So possibly a short, possibly a dead south bridge. But I don't think our problem is going to be the power supply. Let's get some covers off. Alright, the side plate is off, and yeah, this is a 1215 model, by the way, and I'm going to say it has been opened. Somebody has tried to put the warranty sticker back down, but you can see the symbols on there, so it has been tampered with. It definitely has been opened up before, so it is what it is. Let's get a little further into this thing, and let's just see what our problem is, if we can find it. Alright, well, I did go ahead and remove the circuit board from the chassis, so I could get it on the bench here and maybe do a quick check of how much current it's drawing from 12 volts. Got my supply connected. We're going to give it 12 volts and just see what it does. See if that'll tell us anything. 57 milliamps and back up to 320. And hanging. And still hanging. And still hanging. That is unusual. And finally goes back down to a rather high idle current of 55 milliamps. That should be like 10 milliamps. So yeah, that's a new one. I'm not sure what that is, but the idle current definitely looks high. Okay, that's where we are at the moment. Let's look around the board, see if we can figure something out. Alright, so we are ready to take a look around this board and see if we can find something out of the ordinary. Anything, as a matter of fact. Let's see. I don't think we're going to have a short on, say, the 5-volt rail, because I don't think it would have been drawing 300 milliamps. That south bridge, which the south bridge is a 61 GG on this board. This is an EDM 030 with a 61 GG, so at least it's a good, easy one to come up with. Let me get my zeroed out there. That looks pretty good. So, like I said, I don't think we have a short on the 5-volt rail, which, yeah, not likely, I would think. But we could have a short around the south bridge, but it's acting like the south bridge was trying to work in some way. Let me look around this Bluetooth Wi-Fi module. I think that may be ground there. Well, nope, shouldn't be ground on both sides. So that's probably ground, 0.02 or 3. 0.18, so that should not be ground. I'm not sure if that's the 1.8 or the 3.3. Let me check right over here. This is, if you can see, let me make sure it's in the picture here. This little DC-DC converter here just south of the south bridge makes one of them. I can't remember which one this makes. Okay, that's going to be the one though. And the other one is probably on the other side of the board. But there's a 1.8 and a 3.3 for this module, which this module is the J20H100, which I may have some of those. That's probably one of the most common ones, J20H100. But is it a bad Bluetooth module? Is it a bad IC here that generates that voltage? Is it a shorted cap? Which I've seen shorted caps, you know, on the back of the board here. When there's been, you know, roach damage, but this board's completely clean. The system is clean, so I don't think that's going to be the issue. We could just have a capacitor that's decided to die, though. Yeah. So we really don't know. It could be a capacitor. I could look at those. Just for the heck of it, let's just look at them under the microscope. See if any of them just look so painfully obvious, you know, a big crack in them or something. I don't think it's going to be that easy, though. No, any of them. See, some of these are on the 1.8, some are on the 3.3. And I'm not seeing anything obvious. Let's take a look at that. There's that other DC-DC converter right in there. That's not the one that's shorted. I don't believe it's the one on the other side, just below the south bridge. Like there's our south bridge, just below it here. Does seem like F7002 did not blow, or did it? Maybe it did blow. Let's check it and see. I didn't think about that. Let's just see. Maybe it did blow. It did not. Fuse is still good. So our short could still be here or on this DC-DC converter here. And I'm just looking for a good place to solder a wire onto, and I'm thinking this either here, or you could use one of these pads over here. Something with some body to it, because I don't want to, damage the board. So we're not shorted there. We're not shorted on the input, which I'm sure is 5 volts coming in. We are shorted on the output stage here. Yeah. Okay. But maybe a good time to break out the old thermal camera. See if we can figure out which one it is. It may very well be inside the module itself, the Wi-Fi Bluetooth module. You just don't know. All right, well, I think I've got everything set up. I have soldered a lead to into that coil right there where I was measuring the short earlier. And let's see, I am set for my second channel. My power supply is set for 1 volt up to 3 amps of current. So let's enable this and see what gets hot. Hopefully something gets hot. Let's see now. Oh yeah. That is right behind the Wi-Fi Bluetooth module. Right behind it. Right about in there. Yikes, that kind of burns my finger a little. So, yeah, it feels like a capacitor right there behind the module. Good. So it's not the module, because I don't think I have one on hand. Okay, let's zoom in a little closer maybe and get under the microscope and see if we can narrow it down. It feels like there's 2 capacitors side by side right there. So I need to narrow it down a little bit. All right, let's take a look under the microscope just to see if we can narrow this down. I think I see it. If you can see that that capacitor is slightly discolored in the middle. I don't really see a crack, but I do see some discoloration on this one right here. So I'm going to put a little alcohol on it. I'll put alcohol on both of them. Oh, it's still warm, I guess. I haven't given it power yet. Put a little more. All right, now I'm going to turn the power on. Oh, yep. That stood out pretty well. That 2.4 watts of dissipation kind of jumped out at you. So, yeah, well, is that a crack running the length of it now that let's zoom on in here. I'll get it back in focus. No, it's a hair. I thought that was a crack. It's just a piece of fuzz off the cotton swab. But, yeah. Maybe, oh wait, isn't there a crack right around this top end cap right there? That black line where the end cap meets the body of the capacitor. Yep, didn't notice that. You look at this other one right here, you don't see that discoloration along the end caps. So, yeah, I think that's where she failed. I think that's where it failed. Or maybe we can look at it from the side and see something very, very obvious. I'm not sure. Alright, looking at that capacitor from the side, yes, I think you can see that crack right there, but it does run right to that end cap, doesn't it? So, okay, I just want to see if we could see it. Something visible. Also looks like it's been very hot along the bottom edge, doesn't it? Anyway, I think these are all 10 microfarads. I need to check my notes. but I think I have some new ones on hand, so I won't have to pull the donor for it. And I looked it up. It is a 10 microfarad. It is a 0402. And actually, you can see right there, I've got one laid out, ready to be installed. Rather small. This is what I'm using. You can see the Mauser part number. So that's what I'm using. Let's get it installed. See if that doesn't solve all of our issues. I bet it does. Well, that capacitor has been changed, and I have gone ahead and removed my wire because I'm pretty sure that's its only problem. But we will give it a quick check by applying 12 volts to the board and see what our current draw is. We'll double check that polarity. That looks right. And we'll use channel 1 of the supply and see what we get. 300 milliamps, then come back down. Yes, that looks healthy. That looks nice and normal and healthy. Let's see if we can test this board in the chassis, shall we? All right, well, I've got to slip back into the chassis. I think we're ready to test this. I've got the fan hooked up. I've got all the required ribbon cables connected. Power. Let's just see what happens, shall we? Where's the fan spin? Where's the fan spin? Oh, I plugged it in the wrong connector. How did I do that? Try that one. That's a neat trick. Yeah, that's a really neat trick. Hope I didn't blow a fuse. It's always a possibility. So if the Blu-ray drive doesn't work now, then I'll check the fuse before I go through the trouble putting this all back together. I'm going to check those Blu-ray fuses. You can believe that. So, all right, that look. I saw it rebuilding the drive. She's going to come up. Much better. Okay. Well, let me check those fuses and put it all back together, and we'll give it a little better test. Well, she's still going to come up. I thought I would wait until it actually, comes up fully. Not sure how long that's going to take, though. Finally. That took like a minute. Alright, let me get on with it. Well, this PS5 is fully reassembled now, and I'm installing the game off the Blu-ray drive. It seems to be doing just fine. So I think she's going to live. And once again, a tiny little capacitor took the whole thing down. And that happens quite a bit. Well, I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.